Okay, so I just recorded this video to go back over some matrix multiplication examples, especially for those of you who have only done it for the first time last week in last week's tutorial. So there's a wealth of matrix multiplication example videos and things like that on YouTube. There's lots of tutorials and that kind of thing, but a lot of them are tied into bigger math subjects that have a lot of matrix stuff in them, whilst this topic that we're doing this semester doesn't have that much matrix stuff in it. So you don't need to know a lot of the stuff that's in all of those videos, and I think it can be a little bit confusing. So the point here is that I just want to go back over a couple of the examples or similar examples that we went through in the tutorial. And hopefully you can look back on this video or use it to help you if you didn't quite get it last week. So I've got a couple of different examples of matrix multiplication. The first one is when we're looking at two square matrices that we're multiplying together. So the first one I've got up here is we've got two 3 by 3 matrices, and we call them a 3 by 3 matrix because that's what we call the size of this matrix. So we have 3 rows here, 1, 2, 3, and 3 columns, 1, 2, 3. So it's a 3 by 3 matrix. That's just what we call it. It's just a handy name we have for it. And the idea is that if you're multiplying two square matrices together, so two matrices that look like a square, like this one, they're both 3 by 3 matrices. So remember this because this will come in handy. If you've got two 3 by 3 matrices, square matrices, and you're multiplying them together, the final result matrix will also be a 3 by 3 matrix. So what that means is that the final matrix is going to have 3 rows across and 3 columns down. So what that means is when you're trying to multiply these two matrices together, you're going to be coming up with 9 numbers. And if you're calculating any less than that, then you've made some kind of mistake. Okay, so the way that we multiply these two matrices together is that we go rows by columns. And as we went through last week, the overlap of a particular row and a particular column tells you what entry in this result matrix that you're going to be filling out. So, I mean, you can do this in basically any order that you please, but just in the sake of sanity, we're just going to go first row, first column, etc., etc. So we're just going to do it in like a logical order. Okay, so first of all, we've got this first row here, and we're going to be multiplying it by this first column. So what I mean by this overlap is that if you got these two circles and overlapped them onto one matrix, they would be overlapping in this position here, so this one. And so what that means is that the result of multiplying these two, this row and this column together, means that the result is going to pop in here. Now, if you've done this before, well, I don't think you'll be watching this video if you've done this before, but people who are more familiar with multiplying matrices just like to do this step in their head and then plot the answer right here. But if you haven't done it before, or if you're still getting used to it, it's okay to do some working out on the side. And in fact, it's actually much better that you do that, or else you're going to keep making errors, and that's not fun. So let's go ahead and do it. So the way that we do this, I like using a sort of like a claw diagram. So we have this 1 is going to be multiplying this 1, 0 multiplied by -1, and then 0 multiplied by 1. So if you were going to do some working out on the side, and I just put that arrow there to remind you that we're going to be putting the answer into that position. So if you wanted to do some working out on the side, what that could look like is something like this. So that would be 1 times 1 plus 0 from there times -1 plus 0 times 1. And so that's going to be 1 plus 0 plus 0, which is equal to 1. So what that means is that we put this 1 into this position here. Okay, I'm just going to rub this off as I do it, or else I'm going to run out of board space really quickly. So what we have next is we're going to be doing I should have thought this out a bit earlier. Sorry, it's going to get a little bit messy, but hopefully it gives you some idea of what's going on. Alright, so we're going to be doing the first row again, but this time we're going to be looking at the second column. So if you think of our little overlap diagram, this first row and this second column here are going to overlap in this position here, because this position is both in the first row and in the second column. So we're going to do much of the same again. This is going to look like 1 times 2 plus 0 times 0 plus 0 times 3. And so that's going to equal 2 plus 0 plus 0, which is equal to 2. And so that 2 goes in here. And so on and so forth. So we're now doing first row and then third column. Circle the third column. So our overlap is going to be the position that's in the first row and the third column, which is going to be in the first row and third column of the result matrix. So this position is going to be equal to 1 times 0 plus 0 times -1 plus 0 times 0, which is equal to, well, 0 plus 0 plus 0, which is 0. So that goes in there. And that's our first row done. So now what we do is we move on from the first row. Sorry, this is very messy. First row to the second row. And so now we're looking at the second row and we start again. So unsurprisingly, first of all, we're going to be doing the second row multiplied by the first column. And again, think about our overlap. Second row, first column, they're going to be overlapping second row, first column. So this entry here. And let's do our working out on the side. Sorry, this is about to go to sleep. Okay. All right, so we have, second column, second row, sorry, excuse me, second row. We have 1 times 1 plus 0 times -1 plus -1 multiplied by 1, which is equal to 1 plus 0 plus -1, which is equal to, well, 0. I'll draw a nicer one. Next, what do we have? Cool, so we have second row multiplied by the second column. We're moving on to the second column. Our overlap is going to be second row, second column position, so it's going to be here. And it's going to be equal to 1 multiplied by 2 plus 0 multiplied by 0 plus -1 multiplied by 3. That's a -1 there. So that's going to be equal to 2 plus 0 plus -3, which is equal to -3. So that's going to be equal to -1. And that's what goes here, is our -1. Now, unsurprisingly, we're going to be moving on from second row to third column. And if you're getting bored, you can just skip ahead. That's the beauty of videos like this. So 1 there. Okay, so second row, third column, second row, third column, that position there. So this is going to be equal to 1 times 0 plus 0 times -1 plus -1 times 0. And that is going to be 0 plus 0 plus 0, which is equal to 0. And I'm just going to quickly double check that I haven't accidentally mucked up anything so far. No, I have not. Okay, cool. Almost there. We just have the last row to go. Third row. No surprises here. We're moving back on to the first column. Okay, third row, first column. Our result is going to be third row, first column. So it's going to be this entry here. And it's going to be equal to 0 times 1 plus 1 times -1 plus -1 times 1, which is going to be equal to 0 plus -1 plus -1, which is equal to -2. I'm a very messy writer. That's -2. Okay. Next we have, I'm not going to rub that out because I'm a bit bored of it, but we're going to multiply this by the second column. Second column there. Okay, so third row, second column, third row, second column. So we're going to be doing this position here. That is going to be equal to 0 times 2 plus 1 times 0 plus -1 times 3. So that's going to be equal to 0 plus 0 plus -3. Yep, so this entry is going to be -3. And then we've got one more entry to go. And it seems like, surprisingly, I haven't made any errors yet. Doing this is a lot like riding a bike. It's actually quite overwhelming and quite stressful and probably quite difficult the first time you do it. But once you get used to it, it's kind of like second nature. And you might make some mistakes every now and then, like I make mistakes like that all the time. But it's one of those things that when you practice it, it becomes much easier. You get really good at it. Okay, so unsurprisingly, our final entry is this one here, and that's because we're going to be multiplying this third row by this third column. So that position is going to be 0 times 0 plus 1 times -1 plus -1 times 0, which is equal to 0 plus -1 plus 0, which is -1. And I've got that correct. I nicked this example from the internet. Okay, cool. So one thing that could have tricked me up here is that there were a lot of negative numbers and a lot of negative signs, which if you're doing a lot of it in your head, you might accidentally make a mistake. Like negatives can trip really smart people up all the time. But the good news is that in this subject that you'll be doing, you actually don't have to deal with negative numbers in matrices a lot, or at all really. It's just an example I nicked off the internet, so that's why there's some in there. Okay, so finally, just quickly, this is the other type of operation that you'll be doing. This matrix here is just a matrix of 1 row and 3 columns. So sometimes we'll call it a row vector. You don't have to worry too much about that. Sometimes I'll slip up and say it, but it's also a matrix. You can also call it a matrix. So what we have here is a row matrix, or a matrix of 1 row multiplied by a square matrix. And the result of that is going to be something that looks like that. So this is going to have 3 entries in it. Feels a bit like Hangman. So it's not like here where you have to find 9 entries. Here you just have to find 3 entries. But they're going to be determined in exactly the same way. So our first entry here, well, let's think about this, right? Here we had to go through each row, and then for each row we had to go through each column. But for here it's a lot easier because we've just got 1 row, and so just for this 1 row We just have to go through those 3 columns and then we're done. So row by first column here, where we've got 2 times 1 plus 0 times 1 plus negative 1 times 0. So just to write that out, and again, first row overlapping the first column, so the result is going to be the first entry in this row matrix. So just to write this all out, we've got 2 times 1 plus 0 times 1 plus negative 1 times 0, which is equal to, sorry this is very messy but hopefully you get it. So 2 plus 0 plus 0, which is equal to 2. That's a 2 there. I'm just going to rub this out. Next, we want to do this row matrix again, so this first row here, and we want to multiply it by the second column. So likewise, it'll be 2 times 5 plus 0 times 1 plus negative 1 times negative 1. So to write that all out, this entry here will be equal to 2 times 5 plus 0 times 1 plus negative 1 times negative 1, which is equal to 10 plus 0 plus 1, which is going to be equal to 11. So that's an 11 there. Again, same old, same old. Finally, we're going to be doing this row by this column here. The last column, unsurprisingly, the answer goes there. So it's going to be, that one will be 2 times negative 7 plus 0 times 0 plus negative 1 times 1. So much arithmetic. That's negative 14 plus 0 plus negative 1, which is equal to negative 15. And I have surprisingly gotten that right. Again, just like with this other matrix, you actually won't be dealing with too many negative numbers. So don't worry about that. What you will worry about is fractions, but I didn't want to do any fractions today because I couldn't be bothered. So that's fine. The process is still the same. That should be it. Hopefully this helps, and good luck.